I was invited by the Miami JVM Group to present my journey into Java development on the Raspberry Pi. This video contains the part of the presentation that gives you an intro to Pi4J, some of its history and the current state. And we look at a basic example and a more extended one, with a demo of a Vaadin and Spring Boot application controlling several electronic components. Let's jump in. Pi4J is a project intended to provide a friendly object-oriented I/O API and implementation libraries for Java programmers to access the full I/O capabilities of the Raspberry Pi platform. So it wants to help you to be able to control electronics through the Raspberry Pi. So it does this by implementing the application. So you as a developer only need to do the business logic. How you actually communicate with electronic components is handled by the library. So this library already exists also a long time. I think it was started in 2012 by Robert Savage from the US. And he created also a second version of it, and then it became a side project for him, and that's when that was around the time that I was writing the book. So I took over the documentation part of it. We have some new contributors to the project, Tom Aerts, Robert van Berg, and then even university and others have joined the project. So we have now a very up-to-date version of this Pi4J project. So it is a library you insert into your project. It contains native libraries which can communicate with the hardware of the Raspberry Pi and allow you to have GPIO, so simple toggling on and off or reading a button state, I2C, SPI, serial communication, PM. So different types of control of electronic components can be done with Pi4J. We had a bit of a blocker at some point when the Raspberry Pi 5 was announced, because Raspberry Pi made the decision to have a separate chip on the board that sits in between the SoC and the GPIOs. And their idea is to have one unified way of controlling those pins and being able to evolve the architecture of the CPU and the GPU independently. So if there is some new type of CPU, GPU, which would be interesting for Raspberry Pi, for a Raspberry Pi 6 or a similar device, so that they have this other chip to make it easy to evolve. And we were blocked with the Pi4J project because that new chip didn't work with what we had in the code. And then it was really nice to see that someone of the users, again, a student who was using it for his student project, decided to implement a provider which was compatible with the Raspberry Pi 5. So Pi4J is compatible with the Raspberry Pi 5, not fully yet, but we just had a merge request this morning. New features are coming in very fast. Another thing we're doing inside this library is keeping track of all the boards. Let me show you this. Let me first go to the website. So if you're interested in the Pi4J project, we have pi4j.com. The goal of this project, of this website, is of course to document the Pi4J library, of course, but also to be a starting point for everyone who wants to do electronics programming with Java. We even have examples here like, let me check, like controlling a LED strip. So controlling a LED strip, let me put off the audio. Let me check where I have it here. So controlling a LED strip like this, we actually don't use the Pi4J library. We use just serial communication and a dedicated hardware device. So also that is documented here on the website. You can also find JavaFX examples, how to start a JavaFX application, making sure you have the right runtime and everything started. So a lot of examples. JBang is used here. JBang, if you don't know JBang, it's a perfect way to run single file Java applications with dependencies. So if you have, let me try to find an example here. Like for this example, it needs dependencies. So that means that in normal world, you would create a Maven project with a POM file. but with GBang, you can actually do everything inside one file. You define your dependencies, and then you can execute this with GBang and your Java file, and it will fetch the dependencies, compile everything, and run it. So also this is documented here, and a lot of other things. So if you want to get started with Java on Raspberry Pi, go check pi4j.com, the website with all the documentation. So as I said, examples with projects containing Pi4J, but also just how do you install Java runtime on the Raspberry Pi. The other site I wanted to show you is api.pi4j.com. This actually is, again, a Java application. Let me try to show this. It's a Java application running on the Raspberry Pi 4. It's a Vaadin application, so we have the user interface is done with Vaadin, and it exposes some of the information which is in the Pi4J library, being all the available Raspberry Pi models. So you can find them here, like for instance, the Raspberry Pi 5, that's the latest one. And since last week, we also have the 16 gigabyte version. So all that kind of information is here. And then for those 40 pins, which pin can be used for which use case is also documented here. Of course, because this is a Java application with Spring and Swagger, means we can also have all this kind of information through a REST interface. It's a gimmick, I know, but we can do it. So why wouldn't we try to do that? So if we go forward, and thanks to finaltech.com, this is running on a Raspberry Pi in Czech, in Prague. So they are doing the hosting for free for us of this little application, api.pi4j.com, on a Raspberry Pi board. Now, the minimal example, the hello world of electronics programming, is blinking a LED. So when I succeeded in doing that a few days in my journey of learning Java on the Raspberry Pi, I was able to blink a LED. That's really an aha moment, that you can really control something physically through Java code. It's so fun when you reach that phase. So all the examples, or almost all the examples on the Pi4J website, are based on this, a very simple setup where you have one LED that you can blink or put it on and off, and a button. And so that means that you have a digital output to turn on and off the LED, and a digital input to read if a button is pressed or not. So both of these are digital states, a 1 or a 0. Now, blinking a LED is very easy with Pi4J. You actually only need a few lines. So first you initialize a new context. What this actually does is check on which type of board it's running. Because as I said, the way we need to talk to these digital pins, to these GPIOs, is different for a Raspberry Pi 4 and a 5. So it detects which board it's running on, and it will load the correct provider. So there are different modules in there in the library. And if they are packaged in your application or available in the class pod, we can pick them and use the right ones. And then creating a digital output so that we can put a pin on high or low, 3.3 volt or 0 volt, is just asking Pi4J to create a digital output on a specific pin. Watch out with the numbers. As you can see, pinlet 22 is actually pin 15. You can see that here. Pin 15, so the physical pin, the number is 1, 2, 3, 4, 5, 6, and so on. But the physical pin 15 has the BCM number 22, and the 22 is the number you need in the code. So this one. So at that moment, we have a LED, a Java object, which is linked to a LED, to a little light. So now we can toggle that LED, so we can put it to low, being 0, being 0 volt, or we can put it to high, being a 1 or true, or in this case 3 volt 3. So we can put on the LED, and we then can have it in sleep mode, and then sleep in the loop. So the LED is not only the physical thing, but it's also a Java object. So we can ask, what is your state? Are you high or not, or low? And then toggle it. Okay. And that's how it looks like when you're running the application. So the full minimal example application reads the button state. And if you press the button, then the sleep becomes a bit shorter. And if you have pressed the button 5 times, the application stops. So you see in the background, the log output of this application. So what you're seeing here on the screen is Visual Studio Code running on a Raspberry Pi, this one, a Raspberry Pi 4. Don't mind the big fancy cooler here. I am an influencer. That's the only thing I ever got for free, but I had to put it on my Raspberry Pi because it looks so fancy. Now, with everything what we have now seen, let's build something more complex and have a short demo of what we can do with all this. I'm going to use an L-Crow Pi, the left one on this screen. So you can put a Raspberry Pi inside. The Raspberry Pi connects to these pins inside that little suitcase. It has a little screen. And it has a lot of different components. So all these components are pre-wired, so you cannot mess up the wiring. For some components, because there's so many in the suitcase, you need to toggle some of these dip switches. And they also have a newer version of the CrowPi, which has a bigger screen. It has a built-in keyboard. The left one doesn't have a keyboard. The right one has a keyboard, which is wireless, and you can take it out of the suitcase or the little suitcase or the laptop case, and then you have all the components below it. Thanks to the FHNW University of Switzerland, we have examples in Java for all these components. It was a student project. 2 students worked on this for a year. And they had the most challenging part was the temperature sensor, which requires very strict timing. But they created very nice examples for all these components. And I am a true developer, meaning that I'm really lazy. And if I can copy something, I will do so. So I used some of their code in the demo application that you will see. Of course, the whole Pi4J project is an open source project. Also, all the examples are open source, meaning that you can find all these code examples on the Pi4J GitHub account. As you can see here, you have a lot of different applications, apps, as you can see from the name. So if you run this application, it will ask you which of these apps need to be executed. And it will do some pre-programmed things, like, for instance, on an LCD display, it will put a message on the LED matrix. It will put some images and so on. So as a demo of what this CrowPi can do, but that also means that you can indeed reuse that code to have your own implementation on top of it. Exactly what I have done. So I've used that code. Then I went to start.vaadin.com to create for me a basic UI that I could extend with a few screens, for each component a screen. If you don't know Vaadin, really take a look at it. It's amazing. It's full UI, web UI development within Java. So within Java, you create every screen that you see. It's very close to what you can do with JavaFX, one of my other loves, but then for the web. So if you never used Vaadin before, please take a look at it. It's really amazing. Now, what I've done in this demo is I combined a few ways of how to communicate with electronics components. Like a LED, as I said before, is just a digital output. It's on or off. A touch is a digital input. You touch it or you don't touch it, 1 or 0, true or false. An LCD display and the 7-segment displays in this CrowPi need to be controlled with I2C. Is a way of a protocol, a way of communicating with electronic components. The same for SPI, which is used by the LED matrix. And the buzzer uses PWM, pulse width modulation. It's very fast toggling on and off the power, and then the duration of how long the power is on influences the buzzer, and you will see it or hear it. One important topic when you are controlling electronic components is that you really need to understand bits and bytes. And it could look trivial, but when I did film school, so I never went to computer education, and I turned back from editing movies back to it was at the time when digital video started, back to the internet, because I needed to put those company videos on a website and make a CMS system for it. So I never learned the real basics of computers. And of course, I use these hex values on a website, RGB, turn a web page, give it a color. But what's inside those FF? I really needed to learn that again, and discover that 8 bits define a byte and how you convert one to another. So for most of you, I'm really telling not really telling something new, but it's all based on the power of 2, and you start calculating something, and this is a really boring slide. So I found a very nice movie which illustrates perfectly how this works. So this is another fun project, a weekend project, maybe something to do with your kids. Make a binary counter and at the same time have a fun project. So this is how binary values get converted into bytes and how you get into a number value. And why is it important is because some of these electronic components really need that kind of control, or that's how you control them. Like for instance, this 7 segments display. So it has 7 segments to form a number, and then the 8th one is the dot. So with 8 bits, 8 times true or false, you define what is displayed on this kind of display. And let's use 6D as an example. 6D converts into 0, 1, 1, 0, 1, 1, 0, 1, which turns a display like this into a 5. So with one hex value, 8 bits, you decide what is displayed on this little display. And I find that amazing because I've done a lot of web service development, and we're used to exchanging data with JSON. And if you compare all the data which is inside this one hex value, this one byte, it's actually only needing one char. If you convert that to XML, you end up with something like this. So stuff that we are sending between web services in a structure like this, where we have a lot of true-false values, we actually could do that with a single byte, or we could reduce the size of the data that we are sending back and forth between microservices. For instance, we could reduce that a lot and make systems cheaper and use less electricity. So this was also an eye-opener for me, how much data can be structured into one single hex value. If you compare that, this is then the same thing in JSON, 250 characters. The same thing in YAML, 202 characters. So all this information that you see here fits in one number value between 0 and 255. And that's amazing to me, because that's how you control a 7-segment display like this. By the way, I think you now understand why I use the CrowPi for this demo, because this is the setup if you want to do this by hand. You need all these wires, need all these resistors to control a display like that. And you see that there's even a chip in between. The Raspberry Pi has more than enough GPIOs to control 8 segments. But if you want to have a few of these, then it becomes more of a challenge. And with a chip like this in between an IC, you actually only need one connection. So you only send the number value, that's 6D, and it will turn on and off the 8 outputs of that chip depending on based on that number. Okay, let me go into the code of this little Vaadin application that I wanted to show you. So I have this, so this is a Maven project, a very simple Maven project. So what do we have as dependencies? We have Vaadin here. We have Spring Boot, things you all know, I think. We have some Pi4J dependencies. And that's it. The rest is testing. So if you go into the application, the main layout, this is how you build the main UI of a Vaadin web application. And then you see here that we have navigation items, and each of these navigation items links to a specific page. What I also have here in the background is a service. Again, typical Spring Boot use case. We have a service which acts as a singleton, if you want to use that name, which controls all the devices on the CrowPi that we're going to use. So if this service is initialized, it initializes each of these components. I have split this up like this in this example. If you want to reuse this for another demo, you only need to use the things that you actually need. Like for instance, a LED, it uses a longer way of defining a LED, but that's the same result as we've seen before in that one line. It also initializes a touch, which is an input. So it's a button press or not. We have an LCD display, we have a LED matrix. And here, like for instance, this LCD display component, this is code taken a full copy of the CrowPi project, which exists on the Pi4J website. So no original code here. This is really a copy of what already existed and was created by the students for the Pi4J project. And if we have initialized the LCD display, we immediately put hello world on it, and we have something on the display. Okay, there are other here. They're all created and initialized at the start of the application. The LCD displays, I've shown it. This is a view of the matrix. So the matrix is an 8 by 8. Let me show you. So the matrix is this one. So it's 8 rows of 8 LEDs. Okay. And we can put a symbol on there. And again, on this UI, we have buttons. If you press a button, we have a click listener, and it will put a matrix symbol on the screen. And here you see, for instance, I think I said at the beginning, you will understand what the hex value meant that led to a heart being displayed on this matrix. It's here. So on the first row, we have the hex value 66. Then we have the FF. So FF meaning all 8 bits turned on. So we have a full row of LEDs being turned on. So that's how you define an image here. We have the same thing for a segment display. So the minus only has the center, and so on and so on. So this is all Java code. This should all look very familiar to all of you. And it combines the code to create a user interface with the Pi4J service to really interact with the electronic components. But as you see here, this is all just plain Java code. So what's really happening on the electronics, you don't care. You don't need to know a lot about it. Of course, you can dive into here and then see that, for instance, the 7-segment component uses an I2C configuration. It is controlled through I2C. You will find addresses and buses and stuff like that. So as soon as you want to learn more, you can dive into this code and see how everything is constructed here. But some of these things can become really complex. I'm not sure about Dun, dun, dun. I think the LCD system is pretty complex. You have some bit toggling and stuff like that going on, but even then, it's really understandable Java code. Okay, so this is the code. Let me go back to my browser because I have this application now running for you. So this application is running on that GrowPy next to me. So let me show you this thing here. Voila. Okay. So it's running on the Raspberry Pi 4. It is using world on the first one. This is a demo on row 2. Voila. So you see I can control all this from the Vaadin web interface. The LED matrix, so that's this one, 8 by 8. I can select one of these pre-programmed symbols. So you see for the heart, this is the hex value. So 66 means that we have some LEDs turned on the first row, not all of them. Then FF, we have a full row here. And if we go down, you see that the value changes again because we have less LEDs being turned on. I can even move these in all directions or put another symbol on there. We have a smiley, happy face. Okay. And then the last one, which is controllable here, is the 7 segments. So I can put some, let me turn off the LED matrix because that's given a lot of light and that's why it's a bit dark on your side probably. So I can put numbers on these or even text. So you see that we can have everything there. And then there's a last thing, but you cannot see it, you can only hear it. This thing here, this black thing is a buzzer. So if I select a node, then you see that I can control the output of it. So that's a PWM controller. Okay. I hope you believe that this is really real time. And if you don't believe me, I'm inviting you to follow this link and go to pi4j.ngrok.dev, which is actually, ngrok is a way to expose a service without fiddling around with routers and tunnels and stuff like that. So they are providing a way to expose this Raspberry Pi to the world. And you should be able to control this. So I don't know if someone is trying it. There it is. Someone changed to 333. So here you see now the output of the application on the Raspberry Pi. So on the right top, you have all the commands which are going through the tunnel. So someone is now opening the website. On the left, you see the load on the system, but there's practically no load. So the CPU is really low. And here at the bottom, if someone changes something on the display, or if I press the button, then you see the output of the, trying to see this. So if I push this here, someone put hello on here on the screen. Okay. And we have a smiley. I didn't do anything. I promise. So this is now coming through this Vaadin application, which is now open to the world. And anyone can control it as long as I keep this tunnel open and this Raspberry Pi is powered on. Apparently no one dared to test the buzzer. I did this demo at the Devox conference in Belgium, and I had a few hundred people in the room. I should not have told that. I had a few hundred people in the room, and they were really stress testing the system. And even then, it just worked. You can have a few hundred people on a Vaadin application running in Java on a Raspberry Pi 4, and I think this system has, oh, how much memory does it have? I think it only has 2 gigabytes of memory. So, and this works. You can control electronics through this Java application running on a Raspberry Pi on a computer of, I think 40, $50, euros, not more than that. So everything that we do at work, the Spring type applications that we develop at work, we can just use them as a test, run them on a Raspberry Pi, see how they behave in a restricted environment where you only have a limited amount of memory, a smaller CPU, and stuff like that. So someone said this is cool. Thank you.